Advanced Math Lesson 13. Part A is about intersecting secants. Okay, and so here is a circle. It is being intersected by two secants. And when two secants intersect inside a circle, the measures of the angles formed equal half the sum of the measures of the intercepted arcs. So if we wanted to know the measure of this angle, if we know the measure of arc AC and the measure of arc BD, we could find it. We would add those two arcs and divide by 2, half the sum of the intercepted arcs. And we can prove this, which we're going to do now. So I'm going to call that angle 1, and then we're going to connect B and C here, and see now there's a triangle, and we form some other angles. I'm going to call that 2, I'll call that one 3. Okay, now we need to talk a little bit about angles in this triangle. You know the sum of these 3 angles is 180 degrees. You also know that that angle I labeled with the 1 and this angle add up to 180 degrees as well. Okay, since this angle plus angle 1 is 180, and that very same angle plus these two is 180, that means angle 1 has to be equal to the sum of these, angle 2 plus angle 3. Okay, these are interior angles in the triangle. This one's an exterior angle. The triangle with that one side extended, this is an exterior angle. And the sum of the two remote interior angles, so the one that's not right beside this, is the same as that angle. So I'm just going to write here, measure of angle 1 is equal to measure of angle 2 plus measure of angle 3. Okay, if we add those two, it has to equal the measure of angle 1 because they're both supplementary with that angle. Okay, well, how does that help? Well, let's see. Angle 2 here, the measure of that is half of arc AC. You know that because this is an inscribed angle. It's half of the intercepted arc. So I'll go over here. The measure of angle 2 is half the measure of arc AC. Okay, but also angle 3, that's half of arc BD. Whoops. Got my arc symbol in the wrong place. BD. Okay, and we know if we're trying to find the measure of angle 1, we should be able to add these two according to this remote interior angle thing. So measure of angle 2 plus measure of angle 3, that would be half measure of arc AC plus half measure of arc BD. Well, I can factor a half out of that. And there we go. When I add angles 2 and 3, it's half the measure of the sum of those intercepted arcs. And when I add them, that is the measure of angle 1. It's proven already. Okay, so we're going to go up here and finish this sentence. When two secants intersect inside a circle, the measures of the angles formed equal half the sum of the measures of the intercepted arcs. Okay, and we're going to make a put a sentence here too, because this is going to help you sometimes, and we're just going to go ahead and write a little sentence here. Let's see. The measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. Okay, that's just saying in words what this equation says basically. Those two added give you angle 1. Alright, so now we're ready to move on to part B. And this one is about intersecting secants and tangents, as the heading says. We'll have to draw a few things here. So we might have two secants. We might have a secant and a tangent. We might have two tangents. That's why you've got 3 circles here. Okay. Move that over just a little. And so I guess I'll do a sketch of that. Let's start with two secants. Now these are going to be intersecting outside the circle. And I guess I'll just freehand them. This is just a sketch to talk about. Well, we're actually going to prove these as well. So we have two secants intersecting out here somewhere. I'll go like that. And like that. Okay, there are my two secants. They're intersecting out here. We'll call that point P. Okay, and I guess we'll just do the ABCD thing again. Go A, B, C, D. And we're going to need to make a triangle again, and this time we're going to connect these two. And then there's a triangle right here. Okay, and again, how's that going to help anything? Well, let's label some of these angles in here. Okay, so here's one. This is the one we're going to want to know what the measure of it is in relation to the other things. And then call this one way out here too. And I guess it makes sense if the other one inside the triangle would be 3. Whoops. And then that guy's 4. Okay. So again, we know that my angle 4 here, being an exterior angle, has to equal the sum of 1 and 2. So I guess we'll go ahead and write that. Oh, let's write two secants. Okay. And the measure of angle 4 would equal the measure of angle 1 plus the measure of angle 2. Okay, and angle 1 is the one we're concerned about, so I'm going to go ahead and get that by itself. I'll be subtracting the measure of angle 2. Measure of angle 1 equals measure of angle 4 minus measure of angle 2. Right, just did a little algebra to that. Okay, so the measure of angle 4, measure of angle 1 equals, measure of angle 4 is again, it's an inscribed angle, so it's half the measure of arc AB. And angle 2 over here, another inscribed angle, and that is half of arc CD. I did it again. Because I could have turned that into a C. Okay, CD. And then again, you can factor out a half. Okay, so there we go. The angle made by the intersecting secants is half the difference of the two arcs. It's the larger one out here, the one further away, minus the smaller one that's close to it. So whenever you've got two secants intersecting, you know a lot about the relationships of the arcs and the angles in there. Okay, what if it's a secant and a tangent? Okay, so let's put some secant in here. And then a tangent touches the circle at a point. So we'll put it up here. Not too bad. Okay, you're going to find the same thing happening. So here's our point P again. And then we have, we'll make this one A, where the tangent is touching the circle. And then B, and right in there is C. Okay. And we can form a triangle again by connecting A to B. And we're going to call the one we're interested in angle 1. And these other ones will just be, well, we have a 2, 3, and a 4 again. So 2, 3, 4. Okay, and we have this triangle, and here's an exterior angle, and it's it's the sum of these two. So, this is secant and tangent. So the measure of angle 4 now would be the sum of 1 and 2. And then we're going to rearrange, because when we're trying to solve for is measure of angle 1. So that would be measure of angle 4 minus measure of angle 2. This should look familiar. Measure of angle 4. Okay, so angle 4 is here, and it is inscribed. Its vertex is on the circle. It's half of the intercepted arc, and the intercepted arc would be AB. So half the measure of AB, and 2, well, that'd be half of AC. Okay, and again, you can factor a half out of that. So the measure of angle 1 is, let's move this up a little. Measure of angle 1 is half of measure of AB minus the measure of AC. It'll also happen if both of the segments are tangent. Okay, so that on that last circle, we will put two tangents to this circle and prove this as well. What's the easiest way to do this and have room? Maybe I'll go up there. I'm going to use a ruler this time. I'll do something like that. Okay, there's a tangent. There's a tangent. Okay. So here's our point P. There's A. There's B. Oops, I kind of missed. There's my segment to connect A and B to make a triangle. Okay, and the one we are interested in solving for is here. And I guess we'll call that one 2, and we'll call this one 3. And then we need to get one of these exterior angles again. Doesn't matter that much which one. We'll go here. Okay. So now, again, measure of angle 4 is equal to measures of angle 1 and 2. So I'm just going to go right here and do, 2 tangents. Okay, so the measure of angle 1 is the measure of angle 4 minus the measure of angle 2 again. Okay, 4 is 1 plus 2, so 1 is 4 minus 2. And measure of angle 4, that is here, that's half of this AB. I better put some other points in here so we know which arc we're talking about. I guess I'll put C up here and D down here. Okay, so 4 is half of the measure of arc ADB. So I added the points because they were both going to be called arc AB if I just did the ends. Okay, and then I'm running out of room here. I'm going to go beneath. Measure of angle 2, that is half of ACB. So when we factor out the half, this angle again, you take the further away, the bigger arc, minus the smaller one that's closer, and divide by 2. Measure angle 1 is half the measures of ADB minus the measure of ACB. It works for all 3 cases. That is proven. You'll get to do some with numbers later. Okay, now part C, products of chord segments. I've got my circle with a couple of chords in it. A chord is a segment whose endpoints are on the circle. So we have chord AB and chord CD here. And I also labeled the section, like from here to here is, I guess we should put a there. AP, the length of that is A, the length of BP is B, and so on. And you already know, like this times this is equal to that times that. We're going to prove it now. All these proofs. Okay, so we need triangles for this because we know a lot about triangles already, and we can use that to help figure things out here. So we're going to put a segment there, and we're also going to put one there connecting B and D. And now we have 2 triangles. Let's see, angle CAB here, this inscribed angle is intercepting arc BC. This one is also intercepting BC, so I know angle D and angle A are congruent. All right, angle C is intercepting AD, so is angle B. So I know those 2 are congruent. And I also know these vertical angles are congruent. Therefore, these triangles are similar, which means their sides are proportional. All right, so that means we could say A over C equals D over B. Okay, similar triangles. Triangle ACP is similar to triangle DBP. I named them with the congruent angles in the same order. Okay, and then when we cross multiply, we see that AB equals CD. Well, there, it's already proven. That times that equals that times that. See, aren't proofs fun? We have one section left, and actually, we're going to throw a little thing in here just with some samples with numbers. I promised you they'd be coming, so, and we have space. So let's put, it's kind of rough. So here's my circle, and here are a couple of chords. And we're going to say this is 30, and this is x plus 20. And here's 40, and that's x plus 10. Okay, so that means 30 times x plus 20 equals 40 times x plus 10. So 30x plus 600 equals 40x plus 400. So when I subtract 400, I get 200. And when I subtract 30x, I get 10x. And then I divide by 10, so x is 20. See? Simple. Now, if you want to show the work that I mentioned but didn't write, feel free to go back in and do that. Just where you're subtracting 400 from both sides and 30x from both sides, and then divide by 10. But that's all there is to it. Okay, one section left, and this is products of secant and tangent segments. And so they're going to be intersecting outside. And the first one we're going to do is two secants. Okay, I'll just sketch it again. There, we'll have that. Here's P, and we'll do A, B, C, D. Okay. So for this one, we're going to make two triangles. We have one there. And then, so A, C, P, and B, D, P are the ones we're looking at. All right, angle A here intercepts arc CD, and so does angle B. So those two are congruent. And they overlap out here. So we know the triangles are similar, which means their sides are proportional again. Went up a little too far, I'm sorry. Okay, I have the little crisscross here to complete two triangles. I have A, P, C, and B, P, D. A and B both intercept the same arc. They share angle P. They are similar triangles because their angles are congruent, so the sides are proportional. And so that means let's say AP over PC. Okay, this is from triangle APC. I did this long side over this short side. So from the other one I have BP, and then the short side of this one be PD. Okay, and then I can cross multiply. So AP times PD equals BP times PC. AP times PD equals BP times PC. So we have a relationship of these segments. The way I tend to remember this is, it's the whole thing times the outside equals the whole thing times the outside. Okay, remember it that way if you want to, but it's that whole segment. I'm just going to write whole thing. Times the outside part, that small segment outside, equals the whole thing times the outside. Of the other one. Okay? Then if we have two tangents, the entire thing will be outside because they don't go inside the circle. Let's see. So there's a tangent. There's a tangent. We're intersecting out here at point P. There's A. There's B. Okay. Sorry about that. We aren't doing two tangents. You already know about two tangents. You've known that for quite some time. We're doing a tangent and a secant. I fixed my drawing here and also filled in my other lines. It makes a few different triangles. I've written down the ones we're focusing on. Okay, so we have triangle ABP, that whole big triangle, and then triangle CAP, this one in here. I also already labeled that angle B out here, since it's intercepting AC, and this angle A is intercepting AC. Those two are congruent, and they share P. That's how we know the triangles are similar. Okay, they both have this angle, and therefore the triangles are similar, and their corresponding parts are proportional. So then we would have from ABP, this large one, anyway, that's that. We have room to do one thing down here with numbers in it, I would say. Let's just do this one. Okay, so here's another example, and we have, this is supposed to be a circle, and we'll have tangent and a secant And this little segment out here is 8. This little segment over here is x, and the segment inside there is 12. And we're going to solve for x. So, let's see. For this one, the outside times the whole thing is just 8 times 8. And then for this one, the outside is x times the whole thing is 12 plus x, or x plus 12. And then we solve it. So 64 equals 12x plus x squared. I see an x squared. We could do completing the square. We could do the quadratic formula. I like to see if the thing's going to factor. Let's see. X squared plus 12x minus 64 equals 0. I would need factors of 64 that you subtract to get 12. Well, 8 times 8 won't work, but 4 times 16 would. Okay, so I have x. Okay, so I said 4 and 16. They have to be opposite signs. The larger one has to be positive. That gives me x squared plus 16x minus 4x. That's 12x minus 64. So that works. And this is telling me x is either 4 or negative 16. We're talking about the length of a segment. It's not going to be negative, so x is 4. Okay? Can't be negative for this kind of problem because it's the length of a segment. That's that. I hope you have so much fun with these.